to projectile motion problem number 4. It tells you that an airplane that's traveling at 85 meters per second drops a bowling ball, and the plane is 45 meters above the ground, and it asks you to find the horizontal distance that the bowling ball will travel after it's dropped, as well as the horizontal velocity and vertical velocity of the bowling ball. So since the plane is moving horizontally at 85 meters per second, you know that the horizontal velocity is 85 meters per second. And then in order to find the horizontal distance, you're going to use the equation horizontal distance equals horizontal velocity times time. You know the horizontal velocity, but you don't know the time, so you need to solve for that first. And we're going to do that using the distance equals 1/2 acceleration times time squared plus velocity initial times time. So gives you the distance of 400 meters vertically, so you can plug that in, equals 1/2 the acceleration, which is -10 meters per second squared, and times t squared, which is what you're solving for. And since the bowling ball was dropped out of the plane, there's no initial vertical velocity, so plus 0. And you're solving for t. You have all your other knowns, so then you can get, when you calculate it out, t as 8.944 seconds. And when we come back over here, we now have the velocity and the time, so we can find the horizontal distance by doing the velocity horizontally times the time the ball is in the air, which we just solved for, 944 seconds. And when we multiply those two values together, we get a horizontal distance of 760.263 meters. So now we only have one more component we need to solve for, and that's the vertical velocity upon impact. And we're going to do this by using the velocity final equals acceleration times time plus velocity initial. And we've already established that it has no vertical initial velocity because it was dropped out of the plane. So then we can do velocity final equals acceleration, which is -10 meters per second squared due to gravity, times the time, which we solved for before. And we get a velocity final of 89.44 meters per second. So now we have all of our missing components.